Hello. Hello. So what me and my partner have made for this pre-hackathon challenge is some sort of supply chain management software, but of course it's AI powered by Blackboard IO. So since supply chains are very almost extremely complicated with all the integrations, we decided to simply create a mock supply chain. So imagine you're a company and we didn't bother to give it a name or a story, but here you have a bunch of nodes which represent stuff like ports, customers, which are the purple ones, factories, and warehouses. And each of these locations are connected with paths. And as you can see here, there's trucks that bring a warehouse to a customer. On this side, for the key metrics, which are always very valuable to consider when managing a supply chain, is a service level, which means how many customers are getting their supplies, the average lead time, which is how long it takes to go from one end to the other, which is a factory all the way to a customer on average, and of course the cost index, which is the cost that it takes to go from factory to customer. So the way this management software is powered by AI is that here we will simulate a world event. So for example, there is an earthquake somewhere in, let's say, China, and so this warehouse becomes broken, and suddenly we don't know what to do. We don't know what is the optimal or safest way to keep our supply chain network working and optimal. So this is what the AI agent is for. It's just gonna recommend. It's gonna predict what can happen if a node is disabled, and it's also gonna recommend a solution for it. So here I'm gonna click this button, generate event, and while we wait, the way it works is that it uses Blackboard IO's web search to find some recent relevant events. And then it will use Blackboard again, but this time for another agent, which, based on the news, will do an analysis and see how it affects the current supply chain. So as you can see, these four locations have been hurt by a typhoon in Asia Pacific. And if you verify that it makes sense, yeah, so Taipei, Shenzhen, Shanghai, and Hong Kong are affected, but places like Germany and the USA are not affected. Yes, so this makes sense. So before we go into the recommendations, I want to bring attention to the key metrics which have been affected by the typhoon. And those metrics, the way it works is that, let me just show you actually. So the agent returns mutations to the graph. So based on what happened, some edges become disrupted, and it changes the lead time and the cost per edge. And then here, it kind of just does some math, summarizes the edges to calculate these metrics. So basically, after this event happens, so you get some recommendations, but you also get to see what is likely to happen if you don't do anything about it. So, and then also at the same time, our agent actually returns recommendations for this. So rerouting from one node to another is something that it does often. And again, it will predict the impact on the key metrics. So here it recommends two things: to reroute and then also relocated production. So I guess one of the factories got disrupted. So they're gonna decide for some other factory in Hamburg to start producing what they used to produce. Again, supply chains are very complicated. And now we get to accept or not the changes. Let's do it. And as you can see, they stay disrupted. The key metrics are updated based on what the AI predicts. And yeah, so if you're wondering how some of these features are implemented, like how can we actually rely on the agent to decide where to properly relocate the disrupted factory. So like the stuff that this disrupted factory used to produce should be produced in this one. The way it does that is because we are actually giving it the context of this entire graph. So it knows what goes where, and also for each of the nodes here, we don't really see it on the UI because it's too complicated to implement, but each of these nodes, a customer, a factory, or a warehouse, we have generated a lot of information about these places, what they produce, and how they operate, and those are stored in the knowledge base. So the AI agent has access to both a lot of background data about these entities and the whole flow and structure of the current supply chain.